Okay, here we go. Second to last day of notes of the year. So solving equations with e to the x and the natural log of x. And so that's all we're going to work on today. And this follows right along with using all of the properties of logarithms to solve equations. So we're going to practice some properties. And remember, all these properties come from exponent properties before we work our way through. And we can rewrite all of these things, right? Remember, just like we could take log base b of x is equal to y, and we could rewrite this as b to the y is equal to x. We can rewrite this natural base and the logarithmic, the natural logarithm. And so we can go from one form to the other, and it's kind of just rewriting it, but it might be a little bit confusing when it's in this natural log form versus log base e form. So just remember that even though, like, let's start with example 2, even though there's no number there, there's an e as a base, right? That is a logarithm. So we could rewrite this, right? Just changing form. We're basically starting with that e, and we're circling around e to the 5 is equal to x, and that's it. So we always start with the base, and example 2 is a little tricky because there's no base there, but for the natural logarithm, it's always log base e. I want you to remember that. It's pretty important. And then now we'll do example 1. So we're just rewriting this, right? We're starting with that base. So this would be log base e, and we're circling around of 8 is equal to x. But we don't want to leave it written like that. I want you to think about, we're going to put this in that natural logarithm form. So natural log of 8 is equal to x. So natural log of 8 is equal to x, and that's going to be our final answer. So I want to stay with that natural logarithm versus log base e. And we've talked about these properties. You guys did overall like fantastic on the test on this. And so we're just going to use these properties, the product property, division property, and that power property to separate things out. I'm probably not going to do all, we'll do most of these. So let's start with, we'll do example 3 together, and you guys can do example 4, and then check the notes and make sure you're okay. So if we're going to condense, remember when we're condensing, we can't have a coefficient other than 1 or negative 1. So the first thing we need to do is we need to turn that 2, we're going to use the power property, we're going to turn it into an exponent on that 10. So this becomes the natural log of 10 squared minus the natural log of 5. And so that's not too bad. Now we're going to use the product property at the top of our little chart here. And that's a lie. We're going to use the division property. We're going to go from subtraction to division. And so in this natural log of 10 squared is really natural log of 100, so that's how I'm going to write it. So it's going to be natural log of 100 divided by 5. And so that would just be, we could simplify that, natural log of 20. And it's not asking us to, this is an exact value. It's not asking us to do any more than that, so we're going to stop right there. Later on, we'll approximate some answers. And so that's our properties. We're going to use some of these other properties to simplify some stuff down here. And again, we're not going to do all these. You can do some on your own. But I want you to think about, let's see, like these inverse properties. If we're taking the natural log of e to the x, that's just left with x. And that kind of goes right along with, right, because it comes from log base e of e to the x is equal to x. And remember, if the base and the argument match, you're just left with whatever that is. And this is kind of a new property here. We have e to the natural log of x is equal to x. And so it works the same way, right? We're just left with that x. That x simplifies. And so it's kind of in a different order. And that's it. You're just going to have to remember this one. The natural log of e to the x is equal to x kind of makes sense. This one can be a little trickier, so you just have to remember that that's one of our properties. So I guess let's start with, well, let's do an easy one. Let's do 5 first. And so we have the natural log of e to the 0.15x. And so basically what's happening is this exponent is going to become a coefficient, and we're going to be left with 0.15x times the natural log of e, and the natural log of e is just 1. So we're left with 0.15x as our final answer. And so sometimes that one can be a little tricky. Just have to remember that. And you could always, like if you're unsure, you can't put a variable in your calculator, but you could enter in your calculator natural log of e to the 0.15, and you'll be left your final, when you hit enter, this will become 0.15. And so that's kind of an easy way to check, or if you're kind of confused and you're not remembering properties, you can check some of these properties using your calculator. So let's do, I think let's do 6 next. No, 6 is too easy. You guys are going to do 6 on your own. Let's do 7. So our property, right? Our property is e to the x, or natural log of e to the x, or e to the natural log of x, right? That's equal to x. Now the catch with this is there's a 1, like that coefficient in front of the natural log is a 1. So this property doesn't work unless it's e, and then our exponent is ln of x. So we need to take care of this 2 first. We're just going to move this 2, we're going to turn it into an exponent, and now we can apply the property, and we're left with just x squared. So that's not too bad at all, pretty simple. Let's do example 10. So we're going to start with the quotient, right? We have division. So this is going to become the natural log of 1 minus the natural log of e cubed. And so just like when we did logarithm properties before, anytime we're doing simplifying these natural logs or e's or the natural base, any of these things, we want to look at this and see, can we simplify this? And so this is one of our properties from the first half of this unit. And so remember, log base b of 1 is always equal to 0. It doesn't matter what the base is. If we're taking the logarithm of 1, this is 0. And so this thing is going to simplify to 0. Natural log of 1 is 0. Minus, so the natural log of e cubed, e to the 3rd power, is just 3. And we're left with negative 3. And so that's it. That's not too shabby, not too shabby. You guys can do these other problems. Maybe, yeah, you can do these other problems. So look at the notes, and some of them really are, like they're just really simple, right? Example 8 can be a little tricky. You have to take care of that 3. 6 and 9 are very straightforward. So we need to talk about some solving, and we don't have many solving problems here, and we're done. So you guys probably don't have calculators back yet because the AP pre-cal took it. So you'll have to use some Desmos for some of these things. So when we're solving for these, we can get exact values, and we can also get rounded answers, right? So, and sometimes students have a hard time with exact answers. They kind of seem strange, like it doesn't look like a nice form that you're used to, and that's okay. And so we're just going to solve. And this is kind of like going back to when we're solving using our logarithms and our exponential functions. And so the first thing we're looking at here on example 1, if we're solving this, there's some value of x that makes this statement true, right? So 3 times the natural log of 4x is equal to 24. So we need to get this 4x all by itself, which means we need to get the natural log all by itself. So we're going to divide both sides by 3. And that's going to give me the natural log of 4x is equal to 8. From there, we need to undo the natural log. And there's kind of really like a couple of different ways that we want to look at this. The easiest way would be to convert this from this logarithmic form to exponential form. Remember, this is log base e of 4x, even though it says the natural log of 4 to the x. So we would start with our base, which is e. We're circling around. 8 is equal to 4x. And so we've managed to undo this logarithm, that natural log, to get into these parentheses to get to the 4 and the x. And so at that point, we're just dividing both sides by 4, and we get x is equal to e to the 8 divided by 4. And like, as strange as it sounds, that's our final answer. That is an exact answer. There's no rounding, no nothing. And math people tend to like these types of answers. So even though it looks strange, if this was a word problem, I know it says like exact value, but if this was a word problem, depending on the word problem or units we had, we might convert this into like an approximation for a number. Just because, like, if this was some units of time or like some units like miles, like this is not any type of units that we're like familiar with, right? Like e to the 8 divided by 4, like how many miles is that? We don't know. So that's that one. Let's take a look at, I think you guys, yeah, we'll do this one. We'll do 2. So we're solving, and this is an exponential because we see it's e raised to the power of x, which means we have to get that x all by itself and everything else to the other side. And we're starting, right, reverse order of operations. So we need to move the 2 over. And we've got 4 times e to the x is equal to 178. And at that point, we want to move the 4 over. We want to divide both sides by 4. And we get e to the x is equal to, I think that's 44.5. And so we need to undo the e. And so I'm going to essentially go from that exponential form to logarithmic form. So we start with that log. And I'm going to write this as essentially the x comes down, and the other side is going to become natural log of 44.5. So we're just going the other way, right? We start with that base. Remember that would be log base e of 44.5 is equal to x, but we want to write it in that natural logarithmic form. At this point, we're just going to put this in our calculator and we're going to get an answer. We're going to get an approximate answer, and we're going to round that correctly to the nearest 10th place. All right, so I pulled the calculator up, and if you don't have a calculator, once we get done with this, we'll pull it up on Desmos, and you'll see how to enter this in Desmos. It's not terrible at all. So we're going to hit the LN button. So it's the button on the left-hand side. The third from the bottom says LN, and then we just type 44.5. You guys are going to have to hit enter. And it looks like I can't see my answer, 3.795. And then this wants us to round to the nearest 10th. So we're starting right there. So x is, and I would maybe say approximately, if you don't put the approximate symbols, it's not, I won't mark it wrong. This would be rounded to the 10th would be 3.8. And that is our approximate answer. And I'll show you how to put this in Desmos real quick too. I think you guys probably already have a good idea how to do it. It's not too terrible. So let's go pull up Desmos. Oh, is this going to let me? Ooh, okay, hold on. No, that's not what I wanted. Okay. So we're just going to go to our keyboard, and you guys have your computers. So if you're using your computers, you're just going to use the actual like physical keyboard on your computer. And so, but I don't have a keyboard on my tablet, so LN. And then we're going to go back to our number pad, 44.5, and we get basically the same answer, and I would round that to 1 decimal place, that 10th decimal place. So not too shabby. All right. I want you guys to try 3 and 4. I will pause and work my way through and then come back. All right, so we're back. Hopefully you tried these problems on your own. And if you didn't, pause for a second and try and work your way through it. So we're going to start with number 3. The first thing we need to do is move that 2 down, right? Because we need to undo the natural log. So we're going to turn that 2 into a coefficient. We're going to use the power property. At that point, we're going to divide both sides by 2 to get just the logarithm on one side. So we have the natural log of x minus 3 is equal to 8. And then we're going to undo that logarithm. We're going to rewrite it, go from that logarithmic form to exponential form. And we get e to the 8 is equal to x minus 3. And then we just add 3 to both sides and we get that exact answer. So if you wanted to practice, you could put this in your calculator and get an approximate answer. But it asks for exact, and so that's what we're going to do. All right, let's look at example 4. So we need to get that x. I'm going to zoom in a little bit here. We need to get this x all by itself, which means the first thing we need to do is isolate that e to the 4x. So we are going to move the 7 to the other side. We're going to subtract 7 from both sides. And so we get 6 times e to the 4x is equal to negative 3. At that point, we're going to divide both sides by 6 to get the e to the 4x by itself. And so the left-hand side, the right-hand side becomes negative 3 over 6, which is the same as negative 1/2. And so that's fine. Come down to our next line, and we have e to the 4x is equal to e to the negative half, e to the 4x is equal to negative 1/2. The thing that we haven't dealt a lot with in this class this year, and we don't do a lot of this stuff in Algebra 2 anyway, is e is some positive number. So think about, we're trying to raise e, and we're going to input some x value to get some negative number on this other side. Well, there is no number that we can put in for that x that is going to make this left-hand side negative. So we talked about this a little bit last unit. This thing, if we ignore the negative 1/2, e to the 4x has a horizontal asymptote at y equals 0, and it's never going to cross, and we're never going to get negative range values out, right? And so the way that we have this problem set up right now, this negative 1/2 is a negative range value. It's a negative y value. And we're not going to get negative y values out of this thing. You can try, you can put in any value for x you want. It's never going to be negative. And even if you're probably thinking, well, I'll just put a negative value in there. So if you say that x is negative 1, right? If x is negative 1, this becomes e to the negative 4, which is the same thing, because remember, we don't like those negative exponents, as e to the 4th. Well, e is a positive number. So a positive number raised to any power is going to be a positive number. And so a positive number, 1 is a positive number, divided by a positive number is always going to be a positive number. And so you are never going to get a negative number out of this piece, right? Because 1/2 is not in the range of 4x, of e to the 4x, or of e to the x. And so this is no solution. There is no solution to this equation. We could change this around and make it work, but that's just something I wanted you to see. All right, copy your notes. You can finish those other problems. Check your note, check the answer key or the worked out notes in Google Classroom. Work on your homework. Start working on the review. So start working on that final exam review. You guys should have that. I will have a bunch of problems that I want to work with you guys on Tuesday. And then Friday, we will finish this unit out. And I'll see you Friday.